We are starting now this topic of discrete random variable. But before the start of this topic, let me explain four things which are being used in this part. Number one, the sum of the probabilities is always equal to 1. Then the mean, which is denoted by x bar, or it is also denoted by mu, that is equal to summation of x into probability of x is equal to x. Third is known as to be called variance, which is denoted by sigma square, or it is known as variance of x, that is summation of x square into probability of x equal to x minus mean square there. And the fourth thing is standard deviation, which is the square root of variance. So these are the four things which they will ask in this topic of discrete random variables. And now the question is given to us. Eric has three coins. One of the coin is fair, and the other two coins are each biased, so that the probability of obtaining a head on any throw is 1 over 4, independent of all the other throws. Eric now throws all three at the same time. Event A and B are defined as follows. A is all three coins show the same result. B is at least one of the two biased coins show the head. Show that the probability of B is equal to 7 over 16. Since they show three coins, two of them they are biased and each has probability for the head is 1 over 4, for the tail is 3 by 4. And there is one fair coin which has head and tail probability is the same as 1 over 2 and 1 over 2 there. Since A is the event, then all three throws shows same result. That either there will be three heads or there will be three tails. B is the event that at least two shows on biased coin there. And you are going to show the probability of B is equal to 7 over 16, and this result we are going to show. Since B shows at least two heads here, so that means for B, either there will be two heads or three heads. Now we will make this into this part. Let's say this is fair, which is one point there, and there are two biased points. One is B1 and one is B2. They have to show it that at least two heads. So that means it should be two or three heads. So first we will make the column for these three heads. Then it should be head, head, head. This is possibility one. Possibility two, there are two heads and one tail. So two heads can be like this. It can also be like this. Two heads and one tail, two heads and one tail, two heads and one tail here. So we are now going to calculate the probabilities of all this. So it should be probability of head, 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 with the probability of head, head, tail, with the probability of head, tail, head, with the probability of tail, head, head. Because there are two heads, at least should be shown on that part there. So this will be equal to the first head is fair. Head fair is 1 over 2. Then there is head on the biased, that is 1 over 4. And again head is on the biased, so that is 1 by 4. Plus head is on the fair, that is 1 by 2. Head is on the biased, that is 1 by 4. And tail is on the biased, that is 3 by 4. Plus head is on the fair, that is 1 by 2. Tail is on the biased, that is 3 by 4 into head on the biased, that is 3 by 4. Head, tail, and head on the biased, that is 1 by 4. Plus tail on the biased, tail on the fair, so that is 1 by 2. Head on the biased, that is 1 by 4. And head is on the biased, that is 1 by 4. So this is equal to 1 over 16 to the 32 plus 1 over 32 plus 3 over 32 plus 1 over 32. And that is equal to 1, 2, 3, 5 plus 1, 6. We are talking about the topic of discrete random variables. But for this discrete random variables, we should know these 4 points. First of all, summation of the probability of all x is equal to 1. Then the mean of that one is x bar, that is equal to mu. That thing is equal to summation of x into probability of x equal to x. Then variance of x, that is known as the called sigma square. That thing is equal to summation of x square into probability of x equal to x minus mean square. And the fourth part of this one is standard deviation, and that is the square root of variance of x. And now we will follow this question regarding this topic of discrete random variables. Eric has 3 coins. One of the coin is fair the other two coins are biased so that the probability of obtaining a head on the throw is 1 over 4 independent of all other throws. Eric now throws three throws at the same time. Event A and B are defined as follows. A is the event that all three coins show the same result, and even B is at least one of the biased coins show a head. Show that the probability of B is equal to 7 over 16. So this is part A now. There are two biased coins. So, and the probability on each biased coin for the head is 1 over 4, and for the tail there should be 3 by 4 there. There is one fair coin, and the probability of the fair coin is same. So it is half and half. Now they have defined two events A and B there. So A is the event when all three coins shows same result. And event B is defined there as at least one shows head on biased coins. And we have to prove that the probability of B is equal to 7 over 16. That thing we are going to show. Now we know that there are two classifications of the coins. Two are biased and one is fair. So you can make this classification as fair and the biased one and the biased two there. There are two biased coins and one fair coin there. And now at least one shows a head on biased coin. So that means we will show it like this, that it should be having either all three heads would be there or two heads would be there. So we are going to make a combination of first three heads and then two heads. And then at least one, then there should be equal to one head there. So it means it shows one head or two head or three heads. So first we will make it a possibility that all are showing the heads there. Second one is this is head, this is head, this is tail. Third one is head, tail, head. Fourth one is tail, head, head. Fifth one is head, tail, head, tail. And sixth one is tail, tail, head. Now we will show all these probabilities. So the probability of this one is head, head, head. Head is on the fair, that is 1 by 2. Head is on the biased, that is 1 by 4. Into head is on the biased, so that is also 1 by 4. So it should be equal to 1 over 32. Then this will be head on the fair, that is 1 by 2. Then head is on the biased, that is 1 by 4. And tail is on the biased, so that is 3 by 4. So it should be equal to 3 by 32. Then third possibility is head is on the fair, that is 1 by 2. Into tail on the biased, that is 3 by 4. Into head on the biased, that is 1 by 4. So that is equal to 3 by 32. Then tail is on the fair, that is 1 by 2. Head is on the biased, that is 1 by 4. And head is on the biased, that is 1 by 4. So it should be equal to 1 over 32. Then tail is on the fair, that is 1 by 2. Head on the biased, that is 1 by 4. And tail is on the biased, that is 3 by 4. So that should be equal to 3 by 32. And last one is tail is on the fair, that is 1 by 2 into tail on the biased, that is 3 by 4, and head is on the biased, that is 1 by 4. So that value is equal to 3 by 32. So if we add up all these values, it should be equal to 1 over 32 plus 3 over 32 plus 3 over 32 plus 1 over 32 plus 3 over 32 plus 3 over 32. And that should is equal to 4 plus 3, 7 plus 8 plus 3, 11 plus 3, 14 over what? 32. And if we simplify this thing, it is equal to 2 sevens are 216. So that probability is equal to 7 over 16, which we have to show of this, that probability of B is equal to 7 over 16. Now we select the second part of this. The part now. Probability of A given B. So for the second part, probability of A given that B. That means probability of A intersection B over probability of B is the event that it shows at least one of the results shown there. That is this 7 over. At least one head is shown on the bias dice there. And A intersection with B, that means what? A is what shows all the same point. So it should be only this first part is the event for this A there. And that is equal to probability of A intersection B is equal to 1 over 32 there. And the probability of B, that is already we have calculated, that is equal to 7 over 16. So probability of A given B is equal to A section B is 1 over 32 divided by 7 over 16, or it is equal to 1 over 32 into 16 by 7. So that is equal to 1 over 14. That is the probability of A given B to that. Now, for next part, the random variable x is the number of the heads obtained when Eric throws the three coins. Draw up the probability distribution of x there. Let's say x denotes all the random variables for three throws 0, 1, 2, 3. And now we are making this probability of x is equal to x. So we have thrown for all three throws, that is equal to 3 by, for all three heads, that is 1 by 32. Then for two heads, head, head, tail, head, tail, head, tail, head, head. So that is equal to 3 by 32 plus 3 by 32 plus 1 by 32. So that is equal to 7 by 32. So that is for the two heads. Then for the one head, so option left there is seventh, which is head, tail, tail, and that means first head is their probability is on the fair, there is 1 by 2. Then for the tail for the biased, that is 3 by 4, and then tail for the biased, that is 3 by 4. So that is equal to 9 by 32. So, so these are the three heads for that, for one head. So 3 by 32 plus 3 by 32 plus 9 by 32, and that thing is equal to 15 by 32. So for one head there is 15 over 32. Now for the zero head, that is what all tails, tail, tail, tail. So first tail is from the fair, that is 1 by 2. Then is from the tail, that is 3 by 4. Then is from the tail from the bias, that is 3 by 4. So that should be equal to 9 by 32. So this is the probability distribution table for this. And to take the sum of all this, it should always be equal to 1. 9 plus 15, 24 plus 7, 31 plus 1, 32 over 2. That is equal to 1. So this is the complete solution of this problem where the two biased dice are there and one fair dice are thrown together. Not dice, it's a coin there.